Okay, hello everybody, good afternoon. Welcome to this presentation. The title is How to Modernize All Plans for Double-Digit Improvement. So one thing is the reality that we have outside there. Another thing is what we can see here in the exhibition. Everything is new, everything is cool, fancy. But when you go outside there, many of the plans that are already installed are 10, 20, 50 years old. And not everything that is shown in the typical exhibitions is applicable to the plans that exist today. So first of all, who is Belden? Belden is a network infrastructure and data solutions provider. What we do is we connect the physical assets in the plan to the applications that needs to get this data available with the people that is using these applications. We do this in a secure, reliable manner because data matters and data integrity matters most. So who is Belden? Belden we used to call a 120 years old startup. This is because we are changing every few years, we are transforming, and now we are in this journey to transform to data solutions. Belden originally was a cable manufacturer founded 120 years ago in Chicago by Joseph Belden. And as you can see in the images, we were just doing copper cables, a lot of manual work. You can see even here. And we have been evolving to data cables, serial bus, serial protocols cables, and category cables. So let's say Ethernet cables that you are using to connect your laptop to your internet probably are Belden cables. And since a few years, we are transforming to data acquisition, data monitoring, and data networking solutions. You can see that we have, in the next slide, we are automating the plans, but this does not mean that we are integrating operations. We have been able to move manual work to automated work through machines, but in many cases, these machines are 50, 60, even 70 years old. So imagine 50 years ago, where were you? How the world was looking like? Most of you are attached to a mobile phone. Think about how even telephony was 50 years ago. So these are the kind of machines that we have in our plant. So this is a typical Belden plant that we produce cables. And to produce cables, the first step is we buy the copper bars and we do copper extrusion. So this means that from a copper bar that is probably this size, we are making copper wires that are the thick of a hair. Combining all these wires into, let's say, bigger wires, we build the cables that you are using today, for instance, at home. So this means that the process needs to be sustainable. The process generates a lot of scrap. So once we are building a cable reel that sometimes is 300 meters, 1,000 meters, if the cable is broken at any point or one wire is broken at any point, the scrap is the full reel of cable. No matter if you have produced 500 meters, 20 meters, or 800 meters. We need to start from scratch. So monitoring the conditions of the machines, vibration, temperature, the tension on the extrusion machinery is very important for us, and is where we generate some of the savings. So you see here that the changeover in the production line contributes to 7% of the scrap. We have around 20% time loss due to changeover and equipment efficiency. And due to the high amount of different SKUs, optimizing the scheduling of the production is also critical for us. When we look to the Belden factories, and this is important, we distinguish between two types of factories. One are the more discrete production sites where we make made-to-order products, where the changeover is implicit in the manufacturing process, so it's not that critical. And then we have the cable manufacturing plants that are made to stock. So this means that the higher time we can run the machines doing the same SKU, the better for the efficiency. The more time we can produce without stopping is better. We have started this deployment of these digitalization solutions at the 7 plants that are mainly doing made-to-stock products, because it's where the efficiency gains are more sustainable. When we look to these kind of factories, there are mainly 4 types of challenges. The first one is the machines are old. They don't have any kind of data port. They don't have any sensor integrated. You can monitor anything about the machine. The second is that you have sometimes some islands of information. The islands are not connected. IT and OT are completely 2 different worlds. Maybe OT does not even exist. So you have some guys on the IT department managing emails, managing some other things from the company, but it's only the IT portion. There is nothing connected to the machines. There is no way that somebody at the office or remotely can access to the performance of the machines that are used in the factory. The third challenge is about all plants. They have different systems, typically provided by different vendors. In the case of Belden, we also add that we acquire some companies. So this means that we acquire also factories that were built by somebody else. This increases the complexity of the data formats and data sources. We have multiple PLC vendors, multiple SCADA vendors, different machines, and each of them runs completely different. So this is part of the complexity that we try to leverage when we do retrofitting and brownfield projects. And the last one, also on the data solutions dimension, is about visualization. Once you start collecting data, how to make it meaningful for the people that has to interact with the data. Typically, you have different systems, energy management, water management, logistics, each of them with different dashboards, each of them with different screens, systems that you need to navigate in order to interpret the data and what's happening in the plant. So this is the fourth challenge that we try to solve. So what we provided in this case in the Richmond factory is a complete OT network. So we were connecting the facilities with the production lines and the warehousing and storage department. We provided secondary sensors to the machines. So in total, around 600 sensors were installed in these 3 areas. We are using different protocols, IO-Link mainly to collect data from the sensors. From some PLCs, we use Modbus to the Ethernet switches. And we are creating islands of information, conduits, based on cybersecurity requirements. And we are connecting the full production facility and the warehouse with the IT department with a gigabit redundant ring. And all of this is allowing the operators to access the machines and to have real-time information on what's going on. In parallel of what is done on premise, we are also connecting the full factory through gateways and collecting this data to inject into the cloud, because the end purpose of this project here is to be able to monitor the 7 plants that we are digitalizing in parallel and to benchmark between machines and processes to extract insights, and learnings from one plant can be applied to another plant, especially on the energy consumption topic that is really a hot topic now. So on the capabilities that we are providing, as mentioned, we are digitalizing assets by secondary sensing. So we are letting the machine run as it is running today. We are just adding on top some sensors, and we are collecting this data directly to a single data lake. Second is we are also integrating convergence. This means wireless and wired networks together. We are also connecting IT and OT together. So for the experience of the plant managers is totally seamless. They see all the assets as they were sitting together to the asset, and they don't need to worry about if the asset is located outside of the main building or in another building or in a different production floor. So then we are making, with cybersecurity, the aggregation network together with the IT department. So what we are doing is data provisioning. So we are able to put data available for the different applications in real time that they need to use this. So this means that the machine or the performance of a machine or a conveyor belt has impact on the OEE, has impact on warehousing, has impact on energy consumption. So we are making the same data available for the 3 applications in real time. And then on the number 4, you see we have also edge computing. So some of the learnings and insights, especially when we are talking about the extrusion machines for the cables, where the temperature is very important. If we detect a variation of the temperature, we can raise an alarm, and then a plant operator can go to the machine and see what's going on. And we can even stop the machine if it's needed. In this kind of production system, stopping the machine is not the most recommended practice. So typically you let the machine run, and if the cable is broken, it will be broken anyway. If you stop the machine and the cable cool down, you need anyway to cut the production and start from scratch. So the important thing is to gain insights in advance so plant operators can go to the machine with enough time to solve the problem before it breaks the cable or causes any other problem. Also, because edge computing, we think this will be very important. Many of the things that are presented in this fair this week or in the last couple of years about artificial intelligence, machine learning, all these models will be developed in the cloud, but they need to be executed at the edge because of the latency and security. And then the last one, the bullet point number 5, is about orchestration. So the Horizon platform provides orchestration for all the edge computing capabilities that we have, and also for all the network devices. So from a single point, and no matter if you have 1 factory or 2, 3 factories, you can orchestrate all the data applications and all the devices and run them together very easily, so people in the factory, they don't need to have this knowledge. This is the second gap that we have when we do brownfield projects, is that people in the factory, they don't have the skills to run this kind of systems. And with this platform, somebody else remotely, also we can run this as a service, we can cover this gap for the customers. So as mentioned, how we build and envision the future is about a convergence of data. We are used to this when we look even to our mobile phone. We have any kind of application, any kind of data available, and the plant managers are somehow expecting the same from their operational data. They want to have in real time data from the assets, data from the suppliers, and if we think about energy consumption, now everybody is integrating renewable generation, mainly solar. How do they integrate this solar generation with the real-time consumption with the machines? How to align operations to the generation in order to reduce the energy bill? All this data is something that needs to be available in a single data plane, in a single data lake, to generate this kind of insights through third-party applications. So Belden is playing on the first, let's say, 5. And the application layer, we partner with other companies that are the ones that they collect the data when the data is available and clean in a single data lake. Can be in the cloud, can be on-premise. And these companies are the ones generating the insights and helping the customers with the use cases. So in the past, we had different systems, typically different sources of information, PLCs, historians with different protocols. We collect this through the Belden Horizon or through OPC UA protocol. We have also the secondary sensing that we are adding to all machines. In order to collect data, this can go in different protocols, IO-Link, Even we can collect data from analog sensors, so does not need to be even digital. And then we have a third set of data sources focused on energy management, typically meters with a Modbus. And there was a set of gateways compiling this information and sending this, in many cases, in parallel to the cloud. This was obviously one solution, but what we propose is through a single platform, do data orchestration, data management, and data contextualization, so we can collect data from different sources, different formats, contextualize, and this is very important because when you are looking to energy consumption, you want exactly to know which machine and when is consuming that peak of energy, and how can you decrease the peak of energy that is consumed at that moment. So if you cannot correlate events, if you cannot correlate data streams, you will never generate insights. And in order to be able to do this different data streams correlation, you need to contextualize the data and to put in the same format. And we can do this at the edge. We don't need to wait to bring this to the cloud. We do this at the edge. Then we do some basic data analytics also at the edge. Again, we can send plan operators to some machines. We can raise some alarms. We can even stop some processes if needed. And we pack this information and we send this information to the cloud and to make available to different services. And is where also the magic happens. But the magic cannot happen unless you have clean contextualized data. And this is the complexity that Belden solves, especially in these brownfield projects. Once you have the data available in the different services, of course, you can create preventive maintenance, you can create digital twins, and also in the demo that we have here in the AWS booth, we have some visualization tools that have been built with third-party partners, and you can see how the integration of the different data sources is coming together in a single pane of glass. So basically, this is the solution that allows us in Richmond, that is a almost 100 years old plan to leverage the power of digitalization. And now I want to play a short video. Let's see if it works.
Belden employed digital automation consultants because we wanted to be close to our customers and really understand customers' challenges so that we can deliver outcomes and deliver data ingestion solutions that would benefit customers in the KPIs they care about. They're experts in factory automations, they're experts in mass transit, for example. We cover different verticals, and they understand customers' challenges and operations very well, and they can help guide customers in their digital transformation journey. We always start from the very top level. What is the strategic goals we're trying to drive? Understanding those most important things that customer wanted to improve, then we can bring those questions onto the shop floor to ensure that we have a comprehensive view of the plant operation to advise customer on their digital roadmap, their maturity level, and what is the top recommendation for customers to improve their efficiency and drive their KPIs.
So as a plant operations team, we knew that we needed a more automated approach to understanding our equipment and our operations of the factory. We reached out to the Belden CIC team to find a solution that could help improve our operations and understanding our operations.
The solution the CIC team has brought is vendor neutral. We have a lot of old equipment. They didn't come in and say, well, you need to upgrade all this equipment because we can't connect to it. We had a good team meeting, we discussed it, and they brought some devices to us. We shared some devices we've used, and it didn't matter what type of devices or who they were coming from. We were able to tie those into the system and utilize that to get the data we need.
Having to adapt and build our network solution design and our overall solution design to still coexist with this legacy technology and legacy protocols has really been a great experience, and something that's a lesson that we will take with us not only here at our internal projects, but with third-party and customer projects all over the world.
The biggest thing that I noticed with the CIC team is the hands-on approach, really seeing the system and understanding the operation and really digging into the details, not just looking at surface level, but getting into the equipment, understanding all of the electronic controls of the equipment, understanding the network, We anticipate double-digit productivity improvements as a result of this endeavor. But I think the bigger one is us better understanding our operations and having a more intelligent discussion about how things operate on the floor.
Okay, so to conclude a bit, this was a small pilot project that we are expanding to 7 factories. Again, the payout of the project is about 1 year. So it totally makes sense to invest in this kind of application, secondary sensor, because at the end, with very little intervention and disruption of the production, you can really gain a lot. So this means 8% OE improvement that was achieved, and a bit more than $500,000, and we are talking about cost of goods sold, COGS, efficiency gain. And this is the micro impact. This is only 1 factory. But when we look this from outside, we know that data is increasing. All of you have read about this, how many trillions of data artificial intelligence will be managing. But the important thing is that the problems that we have today regarding manufacturing and production can be solved without building new factories. So if you look to the last bubble, you have here the asset base. This is the capacity installed today at the wall. We have 6 times global GDP of production capacity in the world that in many cases is underutilized, and we can gain efficiency just by automating and digitalizing some of the plants, and we don't need to build new plants. So really the problem that we have, especially in some parts of the Western world, that we have old factories, can be solved without deploying new resources on the field, just by retrofitting existing factories. So that was all from my side. I think we have a few minutes for questions. If not, you can applaud now. Thank you.